Introduction. Myself, Puru Chaudhary, founder of Bremgan. It's a 3D AI-based company. It pioneer in 3D AI development and blockchain development. Before we start, right, one thing is this is more of a hands-on session. Right, today there will be no hands-on. I will still set up code and run your first substrate node, but especially right, those who wants to explore more on blockchain side of it, there are some prerequisites, right? One of those requisites is you should have at least hands-on one computer language. Substrate uses Rust. Rust is basically a high-level language. It's very fast. It's very portable. It is WebAssembly based also, right? I will come to WebAssembly later. But my point is, if you want to really gain from this session, you need to have some hands-on on Rust, right? So by the time we will have second session on this, I want you guys to brief yourself or familiarize yourself with the Rust. Okay. Second part is those who are coming from, say, Hyperledger Fabric background or Solidity background. We are not building smart contract here, right? So generally, what you do, say in Ethereum itself is a chain, correct? And then you have Ethereum virtual machine that understand Ethereum bytecodes, correct? And that the language that you guys use is say Solidity, right? So in that, what you are doing is you are basically having a development environment and a development tools, right, to basically compile your Solidity into bytecodes and then into some transaction into the blockchain. But here, what we are planning to do is Substrate is a blockchain building framework. With the help of Substrate, you can build your own blockchain like Ethereum. If you have a different use case, right, you can build chain from the scratch. Okay, so this will be a very hardcore kind of a framework. A Substrate is. So today we will touch upon some of the feature that it provides, and I will try to set up code and run the first node, right, and show how things are working, how code are structured, right, how modules are structured, and then which part of the module that we have to build our custom blockchain, right? So we'll touch upon that. So if you guys have any question before me starting, you can ask, or I can start with my first slide. Okay, anyone who is thinking, who is here for, say, writing smart contracts kind of a session, who joined this session for that? Okay, so what I will do now, I will switch this and I will run the node, the first Substrate node, right, or a blockchain node first, and walk you through some of its features, right, and then we can go into the slides. So let me share my screen, my terminal now. So let me bring this up. I'm not able to bring this up because it is full screen. Sorry guys. Okay. So what I will do is I will go to the node. Substrate session 1. So what Substrate do, right? First, Substrate provide you a template to start with. Okay, so it's not. I mean, it's everyone do the same thing. They start with the first template code. You can easily go to Substrate documentation and can get the link of substrate node from there, right? And then given it's a Rust based, substrate is a Rust based, cargo is the package manager for it, right? So say cargo, I am just building it. So this is the raw build. I just check in the code, sorry, check out the code and building it for the first time, right? So it may take some time. Okay. So if you see, right, it created a target here. In target, it is release, and then it has node template as a binary, right? So if I start this node, I will start it like node template, node template dev. Okay. So if you see, this is how your node is being started. There are few things like what is authority, what is grandpa. I will come to that later, right? But you can start your node by checking out the code and building it and running your first binary, right? Once you are able to do that, you can start your chain. And also, if you want to connect to this chain, right, to see basically what is happening, you want some kind of explorer, right? So for that, you can go to Polkadot apps. So it will take some time. Okay. So this is Explorer that is connected to your node that you have started. Okay. So it is saying that current block is latest block is generated in 2 seconds. What is the current block? Current block number is 13, right? So if you see 12 and 13, it is importing the blocks, right? So this is a explorer that you can easily connect to your network, right? I will come to this node and explorer later. I just started with this so that you understand how easy or how opinionated this framework is, so that you can start with just checking out the code and building it for the first time, right? And which component you need to build the custom blockchain and all those things we will cover through slides. And in subsequent next session, we will cover what we are planning to build it once we are done with this workshop. Right. So coming to, let me close this, otherwise the system will hang. Coming to what we are planning to do, right, at the end of say session 3, we want to create our own decentralized GPU marketplace, right? So what it means is GPU currently what is happening, right? So if you have seen GPU, Chat GPT or Mid Journey, a lot of so these are coming from a very big tech, right? They have a bigger pockets and they can buy thousands of these GPU servers to basically build their AI, right? Build their large language models or build their computer vision models. For them, it's easy, right? But there are still people who want to create domain specific smaller models, right? Which may not take say millions of dollars, but few thousands of dollars they want to do it. But if they go to say AWS cloud, right, say for V100, they will charge around say $3 per hour, right? $3 to $30 also sometimes. But if we give a marketplace, distributed or decentralized marketplace, the same price comes down to 30 cents or even sometimes 20 cents, right? There are player in Web2 which has tried to distribute it if not decentralized. We have seen the same server that if you buy it on Amazon or Google Cloud, it 10 times expensive than what you can get it on marketplace, right? So this is where we thought, why not build a decentralized GPU marketplace where anyone with a GPU machine, right, especially gamers, miners, they have their GPU idle, especially with Ethereum move from POW to POS, right? all those POW miners are idle at this point of time. They can actually give their machine to this kind of a marketplace and can earn money, right? So we see multiple use cases for decentralized GPU, and this is where we are planning to build it from scratch, and we have chosen Substrate as one of the framework for building this, right? And you already saw how easy to start with, right? You just checked out the code, build it, and suddenly everything started working, right? What is that everything will come sooner, right? So any question on decentralized GPU, guys, before I move to more deeper into Substrate and other parts? Because this is a business side of it, right? There's no tech side of it. I only explained what is a decentralized GPU marketplace, right? And try to explain why there is a need for it. Any question on that? Okay. Coming to the Substrate now. Okay, so Substrate node, right? What you have seen at the start, I run some command like cargo run and also say binary hyphen dev, right? What it actually means. That binary is nothing but your node, right? Node means your software piece that runs and makes your blockchain, right? Blockchain is run by node, and one of those nodes that you have seen that we started with. Substrate divide these nodes into two categories. One is your runtime and another is your cloud outer node services. So outer node services is sit outside your runtime, and it handles all the boilerplate code or boilerplate activity that blockchain do, right? All blockchains have a networking needs. They need to connect to other peers on a network. So they need a networking module. They need to come to a consensus. They need a consensus module. They need to store all that block information and transaction information inside a block and then inside a storage. For that, they have a key value database. And for handling transactions, they have RPCs. Any request coming from outside can be done via RPC, and RPC can then talk to runtime logic to basically run certain remote procedures. And telemetry is basically your tells about the health of the node. So this is an extra module. You can export it as a Prometheus export data, and then you can see the health of the node across your chain, right? So this is high level what Substrate provide you. It basically divides it into two pieces. One piece that is common to all the blockchain, right? And you don't even have to write any networking module or consensus module or storage transaction RPC or telemetry, right? What it means is you can directly use as it is unless or until you have to change it. It knows that it is providing you by default, but in case if you need to change any of these modules, you can always change it. But most of the cases, you don't have to change any of these boilerplate code or boilerplate modules. It will come out of the box for you. You just have to mention it in your code. It will automatically available to you. Only thing where you build your custom logic is your runtime machine. So runtime is basically your runtime is basically your logic, a business logic, where it's changed the state of a chain, right? So if you see any chain that we talk about, right, it's basically a ledger, right? Whether you see Ethereum or Bitcoin or any other enterprise blockchain, they are in the end they are maintaining a distributed ledger, right? So ledger has a state, and at any point of time, right? And there should be a smart contract which can change the state from state A to state B depending on what has been requested. Similarly, runtime in Substrate is the same thing. It basically your application logic, which basically change the state of the change or state of the distributed ledger, right? And this is where you build your custom logic. Rest is available to you. You don't have to build it from scratch unless needed. But the main thing that you will be working on is this runtime. Other part of this runtime is it can be compiled into WebAssembly, and given it is compiled into WebAssembly, it is platform agnostic, right? WebAssembly basically can run anywhere where you have a WebAssembly virtual machine, right? One of the benefit of keeping WebAssembly as the target platform is if you see Ethereum, right? Anytime a new changes come, it creates a fork out of it, right? Ethereum Classic and Ethereum the Ethereum 2.0, right? They are separate two chain. Why that happened? Because all those upgrades are not forkless. Those upgrades were prone to forking, right? But in case of Substrate, they use WebAssembly as a target platform, and then they can keep their runtime as part of the storage, right, in the WebAssembly also. So by that, when an update happens, there is no forking happening if you are using upgrade on Substrate chain, right? Any question on this, guys? Okay. So this we have already touched briefly. These are the ancillary services that is there in every blockchain, right? You need some kind of a storage. Substrate has a key value storage with it. Then for networking, it depends on P2P, which basically use the lib P2P implementation, which basically peer-to-peer networking. For consensus, as you know, blockchain, how chains are created, right? Chains are created via some kind of a consensus. Consensus, you might have heard about POW, like proof of work, POA, proof of authority, or POS, proof of stake. This substrate framework allows you to create your own consensus algorithm, or you can take some of them out of the box. Like POA, you have Aura. For proof of stake, you have Babe, and for finalization, you have Grandpa and others. Right? You can check the list. There are out of the box consensus algorithm that you can directly put it into runtime, or you can configure it. RPC calls, those who are coming from, say, Ethereum background, right? They must have done some RPC call from web DApp to EVM, correct? So basically, if you have to submit a transaction, you are doing an RPC call. If you want to get a balance for an account, you are doing an RPC call. There are multiple ways to communicate, but RPC is one way where web application connects to your chain, right? So even the RPC calls comes out of the box in Substrate. You don't have to build anything. Telemetry, I already told. It's basically provides you data around the health of the node. And execution environment, I spoke about the execution environment here. That is compiled to WebAssembly, right? Coming more to it, right? I said most of the things are provided by Substrate framework out of the box. The only thing you have to build is your application logic. That application logic is nothing but your runtime, right? Even runtime, they have one framework called Frame, right? This frame, what it does, its frame is basically collection of different palettes, right? So you have seen Aura, Babe, Grandpa, Asset, Treasury, Payment, EVM, right? So all these things are modules, and these modules are called palettes in Substrate, right? So to build your runtime, what you can do is, hey, I don't want to build my own consensus, right? So what Substrate is providing me? Substrate is providing me Aura. Okay, let's put Aura. That's proof of authority consensus, right? Okay, for block finalization, I need the Grandpa, right? I don't want to write my own. So let's pull this parrot also, Grandpa here, right? For any root activity, I need sudo. For managing an asset, I need asset palette. So all these palettes are already available. There are tens of these palette in their catalog, and you can easily use them. In case if none of these suffices, right? In our decentralized GPU case, we need to build something our own. We can always build our own palettes, right? So Substrate allow you a simple framework. If you adhere to certain interfaces, that palette can easily be integrated into your runtime, right? And then that palette will become part of your business logic, right? So Frame is that framework that can help you building the runtime on Substrate. So one thing is Substrate needs a language to write, correct? So what they have done is they have chosen Rust as a language. Rust has a, if you see last 6-7 years, it is the most loved language, loved language on Stack Overflow opinion poll, right? So Rust has a different advantage. Rust is fast. It is as fast as C, C++. It is as carbon free as C, C++. It is portable. It can run on mobile devices or smartwatches. It is memory safe, right? So if you see C, yes, C is fast. C may be one of the fastest language, high level language, but it is not memory safe, right? You still have to handle your memory by your own. But Rust at the compile time itself ensure that your memory management and all those things are taken care. And Rust is WebAssembly first, right? Rust can be compiled or transpiled to a WebAssembly, and WebAssembly can be ported to a browser or embedded devices, right? Anywhere where we have a WebAssembly virtual machine, this code can be run, right? So this is where Rust has been chosen for Substrate as one of the language. And to be honest, it is one of the difficult language also, right? So those who are coming from say Java background or Node.js background, you will find ramp up time more, right? Learning time will be there and it will be on the upper side. Now few features of Substrate. Substrate needs some kind of a storage also. So under the hood, Substrate provides you RocksDB, and there is a experimental DB called Parity DB. So these two databases are key value databases that is being provided to store data on Substrate. Then these key value database are stored by multiple entity within Substrate. It will be used by Substrate runtime. It is used by Substrate clients, and it is used by off-chain workers, right? So don't worry about this off-chain workers and all. It will be covered in subsequent slide. Then some of the storage feature is you can directly query your storage via RPC calls. RPC is just a HTTP call with a remote method that you want to invoke on a storage, right? So any data that you want to store it directly, query directly from the storage, right? You can do it via RPC. So why don't we see it happening right away? So I will start my chain and try to load up some data in storage. So if you see here, right, storing of data is extrinsic. Extrinsic means you are doing some transaction on a chain, right? So given we are working on a template module, I will select template and then do something is the method that will save the value, right? So that is the template method name. For our GPU marketplace, we will use a different method name altogether. So in this case, for Bob, in template module, I want to save a value, right? Say value is say 2023, right? And then submit transaction. Once you submit the transaction, it will generate events and all those things, right? And if I have to query, right, what I said is I can query storage via RPC calls, right? So this view provides an RPC calls also, or chain state also, right? I can do a chain state and then template module and then say give me the value of the something, right? So I say the value of that something that I stored is 2023 and it has given me that value, right? So you can access your storage through RPC call or directly the chain state through RPC call. Okay. Coming to second part, most of the storage you might have heard about this Markle-Patricia tree, correct? So those who have some experience with the blockchain, you might have heard about this tree through which the data is stored, right? From child to parent, parent to genesis block. You can easily calculate it, right? It has log n. Any tree will have a query time of log n, but Substrate use some kind of a mechanism, cache mechanism, to make it faster, right? It has a different data type. You can store a map, hash map kind of a thing in a key value database, or you can store simple value. So simple value we have just seen, right? How to store a value. So moving to next piece. Okay, so few things. Now you are able to create a chain, right?
Sir,
Yeah.
actually, I had a question.
Yeah, go ahead.
As hello,
Yeah, Jananja, go ahead.
uh, as you told previously that we can use only two types of database. The first is parity DB, and the second is another one. And
Mm-hmm.
both databases are key value pair database.
Correct.
So why can't we use Mongo in Substrate? Mongo with Substrate. MongoDB is also a key value pair database.
So okay, that's a good question. Why we cannot use any other database, right?
Yes, sir.
So MongoDB is what kind of a DB? Uh, it's a in-file in-memory DB. So if you are running a node, Janamjay, and you are running a full-fledged database, right? It
Yes,
will be
sir.
difficult. It will be difficult to maintain it, right? But
Okay, sir.
RocksDB is a file-based DB, right? It's an in-memory DB, and a lot of those operations happen in memory, right? Once you start your node, you can easily run query against your node or store data in the node, right? And it is a
Okay.
tree-based DB. But if you can do it, yes, you can do it. I'm not saying you cannot do it, but Substrate framework itself provide you connection directly to RocksDB or ParityDB.
Okay, sir.
Okay. Okay. Any other question? Anyone? Okay, so I will move to off-chain workers. So far what you have seen, right? You have seen that core infrastructure like storage, networking, RPC calls, these are provided by Substrate itself, right? It's basically a configuration. You add it to the configuration and it is available to us. But second thing is uh, you have runtime. Runtime, you know that runtime is something that every node in the chain has to run it, correct? So you know it's an expensive thing. So some of those things cannot be done on chain always, right? So one of the example in our case is if I have to run our AI model, can I run it on each node? The answer is no, right? Even for a single run, I may have to pay thousands of dollars, correct? But for a for a general transaction, right? Say for Ethereum transaction or a Bitcoin transaction, transactions are processed by each and every node, right? And then it is returned to a block, and then block will be finalized to create a chain, correct? So for your needs, right? Not all your needs, blockchain needs requires all the things to be done by all the nodes in the chain, right? It should be done by say a few participants. Then you can use proof of authority or some kind of a staking mechanism like proof of stake that Ethereum 2.0 is using, right? In case if you don't want to process anything, any such thing on chain, right? You need some kind of a off-chain processing, right? So Substrate provide you off-chain workers to perform those tasks, and these tasks are performed local to that node, not across the node, right? So this is very important, and why I'm touching it is for our use case like GPU marketplace, we need high compute intensive task, right? Uh, that is basically running our AI model on GPUs, right? So we don't want it to be run by each of the worker node. So what we will do is we will use off-chain workers, and off-chain worker will help, say in this case, a long-running task or external HTTP service or encryption decryption, right? So in this case, we will use off-chain workers provided by Substrate to perform a long-running task. In this case, running AI model on GPU machine that has been rented to the network, right? And given all these things happen as an external services, these off-chain workers can do either an external call or any task, right? Once the task is completed, these off-chain workers have access to the chain also, right? With that help of transaction, they can write back the data on the chain, right? So take one example. I said uh, uh, person A wants a GPU V100, NVIDIA V100 for 4 hours, right? And there is one GPU, and one GPU has been given, right? So this off-chain worker will load the data to external services, and through which they will get access to the GPU machine for 4 hours, right? After 4 hours, my off-chain worker, what it will do is it will take the metadata. Okay, his machine was up all the time, his machine was correct in specification, like GPU processes is not used by any other aliens, right? So all those reconciliation of the data can happen uh, by off-chain workers, and these off-chain workers, when realize that only 95% of the claims are correct, right? What it means is this guy has given the GPU, but it is only available for 95% of the time, right? Or GPU is only available, but one of the core is not available. In those cases, my off-chain worker will say, don't charge for 4 hours, just charge for 4 multiplied by 0.95. Okay, and then that transaction can be submitted back to Substrate runtime, and then it can go to the on-chain. So it's very important to understand from design perspective. Anytime you have to build your own chain, right? You need to pretty much clear what should go onto the chain, what should be done outside the chain, and if anything that we have done outside the chain, right? And if you have to write it back, you can do it with the help of Substrate off-chain workers, right? So either we will use off-chain workers, or we will use different REST services to achieve this task, right? So we'll take care of that in subsequent session. Now consensus. So I touch upon consensus a little. So in Substrate or most of the blockchain, if any blockchain that you have come across, there are two pieces for consensus. Phase number one is block authoring, right? In say POA kind of a consensus, only few nodes are allowed to author a node, author a block, right? Or a POS kind of proof of stake kind of a consensus, only those who have staked in the network, right? They are allowed to validate or author a block. Similarly, there is a proof of work also that we can cover later. But there are two pieces, right? One, we are able to author the block, right? The algorithm for author or consensus algorithm for author can differ. It can be Aura, it can be Wave, it can be proof of work, it can be proof of something, proof of AI only, right? But there is other piece is finalization, right? It may happen that two blocks point to the same chain, right? So how we ensure that which block is final block or which chain is final chain, and this is done by block finalization. Also, you don't have to write your own block finalization algorithm. Grandpa is one of the algorithm provided by this Substrate that you can directly use, that will take care of the longest chain rule, right? a chain or fork with the longest chain wins, right? So that kind of algorithm grandpa uses to finalize a block on a chain, right? This help basically solving or handling faults if they exist in our network. Any question on this? Okay, so we'll go to the code structure, but I will take a minute break and then I will open up for any questions that you guys have. Feel free to ask any question. If it is small, big, doesn't matter.
One question: where can I get that substrate boilerplate? Is it on GitHub or?
Substrate boilerplate, you can get it from here. Go to substrate docs. In that you have welcome to substrate. Quick start and start a node, right? Here you have that boilerplate code, right? So if I click copy this, right, this is your code. I will show that code in my editor also. Okay.
Okay, got it.
Yeah. And so one important piece is, right, when we are doing any hands-on, so we have to relate what is substrate to our code structure, right? So let me show you where we started. We started with this architecture diagram, and substrate team has developed this template, right, or boilerplate code exactly on this theme, right? So if you see, I talked about three things: palettes, runtime, and a node, right? So starting with palettes is something that you build on your own, right? There are few palettes that is available by framework only, like Aura, Babe, Grandpa. These are consensus algorithm, asset, payment, pseudo, treasury, timestamp, right? These are available within the framework. But there are few things that you have to develop your own, right? So for that, you do it in a palettes directory, right? So this is your simple palettes. If you see, right, we are able to store something 2023, right? So this is that storage value. We will have more complex data type for our GPU marketplace, but you can think of this boilerplate as a way, as a platform to start your journey for building your blockchain, right? Then once palette is done, you create a runtime, right? I said these runtimes are nothing but a combination of palettes, right? So if I open the runtime and then the package manager, this has everything, right? For a template, of course, you need some kind of consensus. They have used POA. You need payment balances because you want to do the some transfer and all those things. Then you need finality like grandpa, right? So this runtime is nothing but amalgamation of every palettes or every module from the frame that you have taken and created a package out of it, right? So what you have now, you have your custom business logic, you have your runtime, right? Now, if you go to the first diagram, there is some outer services also, right? Outer node services. So if runtime and outer node services becomes a single unity, I have my node complete, right? So this is what they have done. They have this node module where if you see their package, right, they are able to SC starts basically for client services. So they are doing all those clients and all those client into a single node and all the runtime, right? So runtime and client becomes your complete node. So this becomes your node, right? So other things are docs and build, but the main things are runtime, palettes, and nodes, right? So start with palette. This is something that you will build if you are building your own custom chain, and we will have it in our coding sessions also. Second is runtime. Runtime is nothing but a collection of palettes. That palettes can come from existing ecosystem, or it can be your custom palettes, right? And that makes your runtime. And node is basically all those boilerplate services or ancillary services or infrastructure services plus your runtime, right? That become nodes. So just 3 folder, all 3 folder utilizes Rust as a code, and we will go through one, right? We don't have to go through node a lot because node will be runtime plus those infrastructure services. We are not writing any infrastructure services. Runtime also we will see because every time we build a custom palettes, right? We have to add it to a runtime. So we will see that those changes happening. And last is we will create at least 1 or 2 custom palettes so that we can see that we can write our own business logic, own custom blockchain for GPU marketplace. ठीक है, नहीं तो feedback ही ले लेते हैं एक एक करके. So Janamjay, why don't we have 5-10 minutes, right? So just to see what kind of audience we have here, right? So Janamjay, why don't you give your feedback on today's session? Are you able to learn anything out of it, or is totally new framework?
Sure, sir. I learned a lot compared to 1 hour session about Substrate. And as you said that it is hard for me to grasp all the concept in a 1 hour lecture. So I'll go get myself familiar with this topic more, and then I will be able to ask some more relevant questions I think without grasping a topic properly, asking an unrelevant question is not a good thing. And I guess I know you, sir, and Ajay, sir, if you both were in DLT lab, I guess.
Yeah. So I know you,
Uh,
Janamjay. Yeah.
uh, yeah, I remember you guys. You were awesome in that session also. So, but I have one question. I wanted to learn about HBX. Matlab, what is this HBX? I wanted to know about something about it.
So I will pass this question to HBX team. HBX team, can you open up your mic and explain what this HBX is all about?
Yes, sure. Thank you, Puru. And thank you, Janmijay, for asking this question. So, uh, welcome everyone to the session, and thank you for joining this session and making it a success. Well, we are here to make everyone learn, earn, and grow. And we are here to make you industry leaders in technology. And we really want that most of the industry leaders should be from India. So, we're providing education as a service, and it's related to blockchain and other emerging technologies. So currently we are running an HBX summer program in which we have opened 5 project streams, and we are having sessions daily on these project streams. On each project streams, like on this decentralized GPU, 4 sessions are planned. This is session 1, and multiple sessions will go on. So along with this, we invite you all to come forward and join us. And if you'd like to build any project, would like to do any research around it, we are there to guide you. Our mentors are there. We have Puru sir, we have Ajay sir to guide you all and make you build something which is impactful for the society and which helps you in your growth. So that is what HBX is doing, and we are looking forward to you all, how much you are able to learn and grow from it. And that actually, I mean, tells our success. So that is the parameter of our success, how much these courses are helping you in your growth. So that's all about HBX. Thank you so much. Any question that we're, we're happy to answer if there is any other question.
Right. So today's session is more about the foundation of Substrate. Next 2 sessions will be more hands-on on building our own blockchain from scratch. Right. You have seen how to build your first node. Correct.
Okay.
So in case if you are more interested into basic of blockchain, Ajay has already scheduled some sessions, so you can join that. It is more relevant to fundamentals of blockchain 101 type kind of session.
Yeah, that will be very helpful. I'll contact her. Okay.
Okay. Okay. Yeah, Isha, you were writing something. I would love to explore more about the things that were explored here and was familiar with what it is, but today I got much more about it. Nice experience. Thanks, Ayusha, for the feedback. If there is no further question, we can drop now, and we'll see you in next session that we will.
Thanks, Sampada, for the feedback as well.
Sampada is saying, sir, it was a nice experience to learn something new. Earlier, I had listened about the blockchain and was familiar with what it is, but today I got to know much more about it. Nice experience. Yeah. So, Sampada, I would suggest if you are new to blockchain, attend Ajay sessions also. That will be more basic, right? And once your fundamentals are clear, then you can correlate what I have gone through in today's session. That will be far easier.
So, guys, we have shared our summer program calendar with all of you over email, WhatsApp. You can just go, have a look at it and just try to attend all of our sessions and be more active on our Discord server as well. The invite link, we have shared it on our chat. If you haven't joined our Discord server, please join.